Good morning, ladies and gentlemen. PG&E sends a bill every month for electricity. What are you paying for?
What are you paying for? Well, duh, electricity. Yeah, what's electricity?
What is electricity?
I know.
Okay, so take a look at the meter that I have here. And you've probably seen one of these. And what does it say on it right there?
Kilowatt hours.
Huh. Okay, so what the heck is a kilowatt hour? Okay, so PG&E charges between 16 cents and 34 cents per kilowatt hour of electricity. What the heck is a kilowatt hour? I'm gonna do this right below here. Oh, hello, look at that. So, okay. Okay, so what is a kilowatt? Well, what is a kilowatt? What type of,
Well, it's a watt. It's a
watt.
bunch of watts. It's 1,000 watts. And
Yeah.
watts are the units of what?
Power.
Yeah.
Okay, and then we've got this multiplication thing right here.
Dot, yeah.
Dot, okay, and then hour, what is hours?
It's a unit of time.
Time, okay. And this looks familiar. So what does this dot represent right here?
Multiplication.
Multiplication, bada boom. And this is energy, people. Okay, and yesterday we saw this equation yesterday, right? In our video?
Yes, we did.
Okay, so when we say that PG charges for kilowatt hours, what we're really talking about is
Yes.
was that good?
No, that's
Okay.
good. It's one of the slides that are coming up, but that's okay.
There we go. I can't remember what on my next slide. Okay, utility companies sell energy. That's what Mr. Boykin was laughing at.
That's okay.
I was like, wait, did I jump the gun?
It's all good.
Okay, so utility companies sell energy. So when you start using all that electricity, what you're really purchasing is the energy, the kilowatt hours. Electrical energy is sold by the kilowatt hour.
That's right.
Yes, it is. Power is the rate at which energy is converted.
From one form to another. Mechanical energy into electrical energy, chemical energy to electrical energy, electrical energy into heat and light, electrical energy into mechanical energy.
And it's a rate, joule per
Yep.
second.
Yep.
How much energy does a 100-watt bulb use if it is left on for 5 hours?
Has your parents ever told you to turn the lights off when you leave a room?
No, all the time. Especially when I was younger, I didn't understand what money was. Understand spending more money, no good. Okay, so how much energy does a 100-watt bulb? Okay, so 100 watts, that's power, but don't we want kilowatt hours?
Let's use
right?
kilowatts.
Okay, kilowatts time, not seconds. Times
You want
hours.
kilowatt hours.
Right? Okay,
Now
so
we could do seconds, so we have to do 5 hours times 60 minutes per hour times 60 seconds per
okay,
minute.
so if you're someone who needs to see them, we haven't gone over the easy way to convert, but if I'm going, I'll do the fast way first. So if we're gonna go from watts to kilowatts, I just move it over 1, 2, 3 times.
Move that decimal.
So this is really 0.100 kilowatts right here, and my hours is
5 hours.
5 hours. Okay, and Boykin, can you do this in your head?
It's going to be 0.5.
0.5. Okay. Hours. So 0.5 kilowatt
Hours.
hours. Okay.
See how simple that is?
Now, if you're like, Miss Moore, I totally did not get this, you could always use the conversion factor. What is it that there's 1,000
1,000 watts and 1 kilowatt.
and 1 kilowatt, and you could set it up and get it, okay? But I'll say that for a rainy day. Don't worry about that. Don't worry about it. Okay. All right. So kilowatt hour must have power in kilowatts and time in hours.
And these units seem large, but they're appropriate for the scale at which we use electrical energy.
Yes. Yes, it is. So we use them because it's necessary with all the big numbers that we get. We don't want them to be scary to look at. So does PG&E, this is an important question.
Sometimes before I ask this, it says, where does electricity come from? They've got the lights on in here. You got the clocks going back there. Where does electricity come from?
It comes from the electrical plant, right, Boykin?
Yeah. Well,
So, where does it come from? How does it get here? And how does it travel?
well, it has to go through wires.
Okay. So, next question, does PG&E lose energy in the wires between the generator and your house?
Well, that's an
Yes.
excellent question.
I'm going to go with yes. Okay. So, yes.
And let's talk about why.
So this slide here says the resistance in a bulb converts electrical energy into heat and light.
Yep. And so the bulb's got high resistance, and we've been doing labs where we calculate how much resistance we've got. But yeah.
And the bulb, the wire in the bulb is a conductor, right?
Yes.
Before we talked about that all conductors, although current can move in a conductor, electrons can move in a conductor, it's not 100% efficient, and what happens is they all have resistance.
Yep.
And when current experiences resistance, that resistance converts that energy into heat and light. And so as
Oftentimes not
electrons-
light, but sometimes
Sometimes.
definitely heat.
In the case of our wires, as we go from the generator to our house, you've got current running through there. It's experiencing resistance, even though it's just a little bit. It's still experiencing resistance, traveling through those wires. And what happens?
It heats up the wire.
It heats up the wires.
Yep.
Those little birdies sitting on the wires are getting their feetsies heat up, right?
That's right.
So is this a good thing or is it not a good thing?
Depends on who you are.
It depends on who you are, okay? So we'll come back to that. The rate of conversion depends on how much current and how much resistance.
Yep.
Okay, the rate of conversion into heat and sometimes light depends on how much current. So more current, what does that mean? And the resistance. Okay, so what does this look like? This is a really helpful equation. The power lost, not just the power, but the power lost heating a conductor. So the power lost as current runs through the wires
Yeah.
is represented by this equation right here.
And we saw this yesterday when we had the toaster. Its power is lost. Well, it's lost. We're using it to make toast.
Exactly. Okay. And so there is, and we saw this equation yesterday.
Yeah.
Okay, power equals I squared R. So this is the power loss heating a conductor. And I wanted to mention one thing. Actually, I'm going to save that part for later. But think about this. If you have more resistance,
Yeah.
you're going to have more power loss.
Oh, I just thought of something. The wires in the toaster had a high resistance, so the current flowing through them used up power, converted the power. However, the wires going into the plug, into the wall, have a much lower resistance. And even though there's the same current flowing, there's much less power lost from the wires. However, sometimes if you notice, you ever use an electrical appliance and go to touch the wire and the wire was warm a little bit? Yeah, that's what we're talking about right here.
Okay, so this equation is really helpful. Let's rock and roll here. So how much power does a space heater, look at that little space heater, with a resistance of 10 ohms, pulling a current of 12 amps use? Okay, so we've got a resistance equals 10 ohms. Current is 12 amps.
I think we're going to use power as I squared R here.
12 amps. Yeah, so we can't just find, we want the power, right? We can't use IV, right? Because we don't have voltage.
Yep.
But we can use I squared R. Okay, so it's just 12 squared amps times 10 ohms.
12 times 12 is 144. 144 times 10 is 1440.
Okay, so.
And the units are?
Watts. Watt? Okay.
What?
What? So that is, that's our power there. Let me go back. Oh, actually, no, we'll start here. Okay. So energy is power times time, right?
Yep.
So it's okay if I say energy instead of power right here. I'm just going to go ahead and put power is I squared R. I'm going to take that, put it right here.
That's right.
Okay.
And so the energy you use depends on how long you've got the heater turned on.
Okay, a heater has a resistance of 10 ohms if it operates at 120 volts, what is the current through it? Okay, so
I recommend you make some
yeah,
space.
no, let me just erase some of this stuff. Okay,
Let's
so
see,
resistance. What does it say? 10 ohms over there?
10 ohms and
Okay.
120 volts.
Okay, 120 volts. And the first thing it wants is current?
Yeah.
Okay, well, let's just keep it simple here. Current is the voltage over the resistance,
That
right?
comes from Ohm's law, V equals
Yeah.
IR.
Okay, so volts is 10. Is 120 volts, and my resistance is 10.
Boys and girls, do we need a calculator for this?
Miss Moore might, but you guys hopefully don't. 12, right?
Yeah.
Okay, 12 amps. That's a lot of amps. Woo.
12 amps.
Okay. So that's the current. What's the next question? What?
Thermal energy is provided by the heater in 12 seconds.
Okay, so this is our equation for energy, right?
Yeah.
We don't have power though. What was that other thing we could put in here?
I squared R.
I squared R times C. We just saw this equation too.
Yep.
Okay, so let's go to plug our stuff in here. So our current is 12 amps, so 12 squared. Our resistance is 10 ohms. And then our time is
10 seconds.
10 seconds. Now, do we need to... 10 seconds is fine,
10
right?
seconds, yeah. We'll do kilowatt hours in a
And
minute.
then, okay. So 144
Times 10,
is 1400 times 10 is
14,000.
4, like this, right?
Yep.
Okay, there we go.
144,000. Yeah, thank you.
144,000.
Or 14,400. Put the comma in. Mr. Boykin needs help.
Right there, 14,400 joules. Okay, that's how I feel every time I read a large number.
Yeah, I know.
I always have it like in my head to see where the comma is. Okay, so the thermal energy provided by the heater is that right there. Cool. Did we need to go to page 522?
Nah.
Okay. Okay, how can PG reduce I squared losses in their transmission wires? I squared losses. This is a technical term they use.
Yeah.
But what does it mean?
Well, it comes from this power is I squared R. And so the resistance of the wires is fixed. You know, the wires that you see on the towers. And so how can they reduce the power lost due to the current flowing through those resistors? That's the big question. This is an important question.
How can PG&E reduce the current that they
So power comes two ways. On the next slide, it shows you that power comes two ways. It's current and voltage.
So momentarily. So if the way that we lose energy is when we travel in the wires and they're generated to us.
Yeah.
Then that means, well, what's traveling in the wires there? It's current.
It's current. You can have power. You can have large current, small voltage, small current, large voltage.
Well,
this would be
seems-
like 10 times 2 or 2 times 10.
It seems like if there was a large amount of current, they would lose a lot of power, right?
Because of this.
Yeah. So I think, yeah, because the more current, it's just gonna all transfer into heat, right?
Yep.
So transform into heat. So what we want, the way that power companies reduce their I squared losses, the energy lost in the current in the wires, is they put as little current as possible through the wires, but they've got high voltage.
Yeah, and you see that on the transmission tower. It says, danger, high voltage.
So those wires have a small, relatively small amount of current running through them, but they do have high voltage.
And they can still deliver the same power to your house.
I love this girl's voice.
I pledge allegiance to the flag
Should we
of the
pause?
United States of America.
Go.
And we're back. Okay, so does PG&E sell power or energy when they charge 16 cents for each kilowatt hour used? Well, what have we just got done talking about? Okay, PG&E sells energy.
That's right.
Kilowatt hours. Kilowatt hours. Just move that bad boy over there.
Remember to stay home if you're ill. If you have any
Okay, so here we are. So energy is power times time. Energy is what PG&E is selling you.
Yeah.
Joules, it's watts per second, and technically
Time
it's
seconds.
kilowatts per hours. Why is that? Well, it's appropriate.
It's because of the scale. If we used watts and seconds, you'd have huge numbers.
Yeah.
In fact, I think the next slide, yeah.
So 1 kilowatt hour is actually equal to 1,000 watts delivered. Oh, I had that right up there earlier.
Yeah.
Okay. So delivered continuously for 3,600 seconds.
Yeah.
So 1 kilowatt hour is equal to this many joules. This is not what your parents want to see on their bill.
Yeah, imagine the bill comes in, it's got scientific notation. They're going to go, what the deuce is this, Martha?
Yeah, they are not about it. So in order to avoid scientific notation and scaring your parents, they use energy, they use kilowatt hours, not just watts. They use hours, not seconds. Okay, so how much energy does a 100-watt bulb use if it's left on the floor, on for 5 hours?
And we want our answer in kilowatt hours.
So, I actually have never shown this to you guys, but I'm just gonna use it real quick. I'll show you how I use it real quick too. So, it says how much energy does 100 watts use, and so we for 5 hours. So we know we want kilowatt hours, right? And right now we've got 100 watts. So watts would be right here.
That's the basic unit. BU stands for the basic unit, and we want to go to kilowatts, which is to the left.
How many times?
1, 2, 3. So you move the decimal 3 places to the left.
1, 2, 3. I start here because that's where it is.
Yeah.
1, 2, 3. So we're really talking about 0.100 kilowatts. If you knew how to do that, great. If you don't, well, here's a little shortcut.
So now you've got 0.100 kilowatts times 5 hours.
Didn't we already do this?
Sounds familiar to me.
Boom, boom, boom. Okay, so 0.5 kilowatt hours. Your answer the units for how much an electric company is charging has got to be kilowatt hours.
Yep.
But wait, there's more. Okay, so we're gonna go. We're bringing it all together with this question. A computer draws 2 amps when operating on 120 volts.
I wonder if this computer's got a sign that says how much power it uses. Nope.
No, not accessible at least.
Not.
Okay, so the question says, first question, A. How much power does it use? Well, this one's, I got I times V.
Yeah.
Let's not make it harder than it has to be. Sorry. I was thinking about the answer. 120 volts. Oops. So that's 240 watts.
240 what?
Huh? What? Okay, so B. If it is on for 7 hours a day, okay, so our time is 7 hours per day. How much energy in kilowatts per day?
So we got it first. Let's find out how many kilowatt hours that is.
Okay.
So it's 7 hours. 240 watts is how many kilowatts?
This is gonna be 1, 2, 3 kilowatts.
Yeah.
Okay, so 0.240 kilowatts. And then times our time, which needs to be in hours. So 7 hours.
Yeah.
Okay, so 0.240 times 0.240 times 7, and I get 1.68.
1.68 kilowatt hours in 1 day.
I'll say per day. Or should I say per day?
No, well, what you've got is you've got hours per day, so yeah.
Like this?
Yeah. So that's per day. Let's say there's 30 days in a month. How many kilowatt hours in a month?
Oh, okay, so we just multiply if there's 30 days
Yeah.
in 1 month. Okay, so just multiplying that.
It's going to be about,
We just multiply it by 30, right?
yeah,
Okay, so times 30, and I get 50.4
50.4 kilowatt hours in a month.
kilowatt hours per month. Okay, and then last but not least,
It's 16 cents per kilowatt hour. How much does it cost to run for a month?
okay, so I have to multiply that by 0.16 then,
So
right?
that's 1.16 kilowatt cents per kilowatt hour. Per kilowatt
Thank you,
hour.
thank you, thank you. Per kilowatt hour, like that. I need to multiply it by
50.4
4
kilowatt hours.
per month. Look how important units are. Okay, kilowatt hours cancel out, kilowatt answers out, and we've got price per month. That's what I'm talking about. Okay, so I got 50 times 0.16, and I've got $8. I'm gonna call it 8.06.
So it's going to cost a little over $8 a month. Okay. Well, gee, that doesn't sound like much. How many electrical things are in your household?
Yeah, this is for your computer.
And should you leave your computer on 24 hours a day just because you don't want to turn it off?
I turn mine off every night. Okay, so
that's it.
That's it. Okay, now do your homework. Page 5, 25, numbers 18 and 20.